Say you're given this question. The limit of sine 3x over x as x approaches 0. If we dare to substitute 0, we will have 0 over 0, which is indeterminate. Now, from the last video, we learned that the limit, let me do this in the next color. We learned that the limit of sine theta over theta as theta approaches 0 is equal to 1. And that is because the denominator has the same coefficient as what is inside the sine function. Here we see that there's a 3 here, but there's a 1 here for the coefficient in the denominator. We need to get them to be the same so we can get the function to be 1, because we know the limit of that function. So what we're going to do, we're going to divide by 3. But if we're going to divide by 3, we must multiply by 3 so that we don't change the function itself. So this is what we would have. Here we can see that we are multiplying by the 3 here and we are dividing by 3 also. So the function isn't changed. Now we can factor out this 3 here because it's a constant multiplying the function. So we can have, oh, by the way, there should be an x right here. So when we factor out that 3, would have 3 times the limit of sine 3x over 3x as x approaches 0. Now we can see that we have a 3x there in the denominator and a 3x here. And we know the limit of this. We know that that limit would be 1. So we'll have the 3, which is here, times the limit of the function, which is 1. So our final answer would be 3. So the limit of this function here as x approaches 0 is equal to 3. And that's how we do a question like this. Now let's take a look at the next question. For a similar question, we have the limit of sine 8x over x as x approaches 0. We now know that we need to have the same coefficient here as the coefficients at here. So we're going to divide by 8, so we'd have a 8 right here. And if we're going to divide by 8, then we must multiply by 8. So we would have this. Now that we have that, we are going to factor out this 8, being that it's a constant, so we'd have this. And now we know that the limit of this is equal to 1, and we're multiplying that 1 by 8, so the limit of this function is equal to 8 as x approaches 0. Now you are given this question. The limit of 3 sine 4x over x as x approaches 0. The first thing you do when you get a question like this, you factor out the constant that is here. So we're going to factor out that 3 and we would have this. From before, we know that we need to have the same coefficient there as the coefficient in the sine function. So we're going to divide by 4 and multiply by 4 at the same time. So we would have 3 times the limit of 4 sine 4x over 4x as x approaches 0. And we know that we are going to factor out this 4 here and multiplying it by this 3, making it 12 times the limit of sine 4x over 4x as x approaches 0. And from the past examples, we know that this now, since the coefficient of the denominator is the coefficient in the function, then we know that this would be equal to 1. And 1 times 12 is equal to 12. So the limit of this function as x approaches 0 is equal to 12. Now you are given this question. The limit of 1 minus sine x as over cos x as x approaches 0. If we do a direct substitution, we would have 1 minus 0, because we know that if we plug in 0 here, we would have sine 0 is 0 over cos 0, which is 1. So the limit of this function, the limit of sine 3x minus 4x cos x all over 2x, and this is as x approaches 0. Say you're given this function, the limit of sine 3x minus 4x times cos x all over 2x, and this is as x approaches 0. The first thing you want to do in a question like this is to factor out this half here. The reason why you'd want to do that is because the argument of the sine function and the cos function is different. So let's factor out this half. Now that we have this, we can split this into two fractions. So we'd have, for this function, from the past example, we already know what to do. We know that the limit of this function will be 3, because we're going to divide by 3 and multiply by 3 at the same time. So we're going to have 3 for that function there. So let's show that. And by the way, this should be in a bracket to say that we're finding the limit of what's inside the red bracket. We're going to write back the half as it was, the big bracket, the limit of x as x approaches 0. Then we're going to multiply by 3, so we're going to have the sine 3x over 3x minus this x cancels this x. Let me do that in the next color so that we can see. This x cancels this x, so we're left with 4 cos x and I want to put back this in this bracket. We know that the limit of this function will be 3. So let's put that 3, and for this function, cos 0, when we direct substitute the 0 here, cos 0 would be 1, so we'd have a 4 here. So we are going to have, we will get a -1 here, so our limit would be -1. Let me put that in red for our final answer. -1/2. That is what our limit would be for this function. So let me scroll back up to the function. The limit of this function as x approaches 0 is equal to -1/2, as we can see here. So that's how you approach a question like this. For clarity, let's do a similar. The limit of sine 5x minus 3x cos x over 5x as x approaches 0. We're going to approach this the same way, so we're going to factor out this 5 here, which would be 1/5 when we factor it out. Even though there is a 5x here, we're going to factor it out the same, so we can do our manipulation for the two functions in the numerator. So let's factor out that 1/5. Our next step is to split the function into two functions. Now, we already know that this function will be 5. We have been doing examples like this for a while, so we know that we're going to divide by 5 and multiply by 5, and this will be 5. So let's just write that 5. And for the next side, put our minus sign. This x will cancel this x, so we're left with 3 cos x. When we find the limit of 3 cos x, we will result with a 3, right? Because 3 times cos x as x approaches 0 is 3. Let me change the column. So inside the bracket we have 5 minus 3, and that would give us a 2, so we'd have 2 over 5. So the limit of this function, let me go back up. The limit of this function as x approaches 0 is equal to 2/5. Limit of half x over sine x as x approaches 0. The first thing you want to do is to factor out that constant there. So when we factor out that constant, we'd have a half times the limit of x over sine x as x approaches 0. And from the last video, we know that the limit of this is equal to 1. So 1 here times the half in blue would give us a half. So the limit of this function as x approaches 0 is equal to a half. Let's do a similar question for clarity. You have the limit of negative 2 over 5x, and all of that is over sine x, and this is as x approaches 0. The first thing we want to do, as before, is to factor out this constant here. When we factor out that constant, we'd have negative 2 over 5 times the limit of, as x approaches 0, of x over sine x. And we know from before that this is equal to 1. The limit of x over sine x is equal to 1. So this 1 times this negative 2 over 5 would result in a negative 2 over 5 for our answer. So the limit of this function as x approaches 0 is equal to negative 2 over 5. And we have been seeing some patterns. We realize when we have a function like this, whatever constant is here is the limit of the function, and this is as x approaches 0. Please remember that. And a next pattern we realize when we have a function like this, so it's always this, because what you're going to do, you're going to multiply by this, so you'd have the a there, and you would have an a here, and you would factor out this a, find the limit of this, which we know would be 1 when this a is not present, and 1 times this a would result in that a. So that's a next pattern that we notice. And I think this is enough example. Let me show you one more example which you already know of. Limit of cos 5x over cos 8x, and this is as x approaches 0. From limits theorem, we know that the limit, let me do that down here. From limits theorem, we know that the limit of f of x over g of x as x approaches 0, or x approaches a, is the same thing as the limit of the function f of x as x approaches a over the limit of the function g of x as x approaches the point A. So that will be the same thing that will be applied here. We already know the limit of each function. We know the limit of cos 5x and we know the limit of cos 8x as x approaches 0. And we both know, and we know that both of them is equal to 1. So let's write that out. The limit of the top function, the function in the numerator, cos 5x as x approaches 0 over the limit of cos 8x as x approaches 0 is equal to 1 in the numerator, 1 in the denominator, which overall equals 1. And this is it for examples and limits of trigonometric function, for now at least. Thank you for watching.